Hi, everyone, and welcome to today's webcast on demystifying multi-cloud for your organization. Glad you could join me. Let's take a look at what I would like to cover in the next 30 minutes or so. I'll start with some high-level introductions to myself and to Thorogood, and then we will look at the cloud evolution journey and what a multi-cloud is. Then we will talk about why organizations are talking about embracing the multi-cloud approach and what are some of the existing common design patterns in the market. We will close the webcast by talking about some of the challenges currently existing while adopting the multi-cloud space and how one could get started with it. Right. So let me start with a quick introduction about myself. My name is Apoorv Tandon and I'm a data and analytics consultant with Thorogood based in our London office. And I'm really excited to share my understanding on multi-cloud. If you have any questions for me, please feel free to get in touch via the contact details on the screen. I will share my contact details again at the end of the presentation. Now, as far as Thorogood as a whole, who are we? What do we do? We are an independent data and analytics specialist consultancy with a focus on data engineering, data science, and data visualization. What that means is that we offer everything from strategies and roadmaps, end to end implementation of cloud solutions, user empowerment training and support, kind of everything across the breadth of that data and analytics space. Our approach is rooted in understanding the business goals and using the capabilities of technology to meet these goals. So, customers and business objectives are at the forefront of our approach. We are a global company with offices and consultants in Asia, Europe, and the Americas. As we are an independent consultancy, meaning that while we partner with many of the leading providers within the data and analytics space, we are not tied to one specific tool or one specific platform. I've just now put up on screen some of the technologies we work with, kind of many of the leaders within the data and analytics space. And this independence allows us to understand an organization's technical landscape, strategic and business objectives for a particular use case, and share an unbiased perspective on the landscape for a particular solution given all these parameters. It also allows us to stay up to date with technology updates across the industry so that we can develop robust modern solutions for our customers. Our clients typically span four data rich verticals: consumer goods, pharmaceutical and health services, banking, and insurance, but not just limited to these, with experience across the board in various functions of these verticals like finance, supply chain and operations, market and retail data, among others. As I said, we'll keep the introduction short, so let's dive in. You may or may not have heard the term multi-cloud before. Let's take a step back and talk about how hosting strategies have changed over time and how multi-cloud came into picture. Way back then, companies hosted all their systems, transaction systems, IT applications, etc. on premises. Think of a server room closet in your office with hardware running all these systems. On-prem systems are purchased, managed, and fully owned by your company. Cloud came around and changed the model. It asked, why should your organization worry about the initial upfront cost of purchasing the hardware and then the cost of running it, the ongoing cost of maintaining the software, any software upgrades over time, and even having that server room closet? Cloud says, let us host and maintain some of those aspects for you. Now, there is a spectrum of cloud hosting services, and we will not go into that here. But the gist of cloud is allowing the service or service providers, someone like Salesforce, Amazon Web Services, Microsoft Azure, Google Cloud Platform, to manage on your behalf. Hybrid cloud makes it clear that it is not an end all or nothing game. If your organization suddenly says that we are moving to the cloud, you will not suddenly move from 0 to 1 overnight. But secondly, you may not necessarily need to move every application, every ERP system to move to the cloud. You may have very good reasons to purposefully keep certain systems on premise. Here, the hybrid cloud strategy allows for a combination of on premise and cloud applications. Now, we're talking about multi-cloud or purposefully leveraging multiple cloud service providers in your organization's architectural strategy. You may hear multi-cloud or hybrid cloud. Just be aware they are sometimes used interchangeably. Hybrid use here specifically incorporates the use of on-premise applications, but in any case, both incorporates the use of multiple cloud service providers. But why are we seeing more and more organizations thinking and planning to apply a multi-cloud strategy? Its benefits are driven from this lack of vendor lock-in. Choose a best machine learning tool across providers, retain a vendor switching threat for competitive pricing, and allow for disaster recovery across platform and reduce risk overall. It is the defined system strategy based of the strategy don't put all your eggs in one basket mantra. These benefits are fantastic and have started seeing our customers inclined towards taking this approach. I will say it's important to consider what a multi cloud strategy means from an internal skill set perspective as well for build, maintenance, and of change management processes outside of just the architectural definition. But with that being said, from an architectural definition standpoint, I would highly recommend researching about cloud agnostic tools in addition to the use of cloud native tools. Cloud agnostic tools like Databricks or Snowflake are easily implemented across the big cloud service providers, aiding in your flexibility to move across services without requiring a new tool set for migration or even upskilling your teams. We are seeing customers define multi-cloud strategies by region, by business function, all the way down to the dataset level. There are many ways that you can define your strategy, and it's important that you are defining it based on what works best for your organization. There are currently four approaches to multi-cloud. They include split cloud, multi-cloud disaster recovery, multi-cloud high availability, and cost management. The split cloud model is really the most common and simplest form of multi-cloud. Now, this model uses one cloud platform to host an organization's test dev environment, but another service cloud platform to run production workloads. Now, another take on the split cloud model we've seen would take a production environment and split the production environment components across multiple cloud platforms. Organizations would do this to take an advantage of services, features, and pricing advantage that is available only in one specific platform. Multiple cloud disaster model is a more recent and actually more complex multi-cloud approach. When you take the multi-cloud approach to DR, you typically do is run your production apps in one cloud platform while maintaining a separate up-to-date copy of those apps on another cloud platform. This defends against the failure of an entire cloud provider. Now, the operation of hosting of a single application across multiple cloud platforms results in what is exactly called high availability type of deployment approach. This type of solution protects those apps from things like DNS, DDoS attacks, regional failures, or even failure of an entire cloud platform. This type of solution results in recovery point objective that theoretically zero in the case of a failure that affects one cloud platform. Now, the least common model in practice is sometimes called the cost management approach. In this approach, organization workloads are dynamically placed on the cloud platform that has the most competitive infrastructure at the time of deployment. This type of solution isn't the easiest to deploy and often has lots of challenges to make it work. Now, that being said, as solutions like Kubernetes improve, you will likely see more and more organizations try to leverage this approach in order to better manage costs. Now, in a similar tangent, we see a lot of vendor agnostic tools gaining popularity, like Databricks or Snowflake, and we'll touch upon one such cloud agnostic tool, Databricks. So, what is Databricks? Databricks builds on the open source Spark platform. Spark is a popular platform for running data analysis and data machine learning at scale. And the team who originally came up with Spark formed a new company to launch Databricks. So Databricks takes all the advantages of Spark platform and extends it to make it easier to set up and use and makes it ready for the enterprise. One way it does it by integrating with Azure, Amazon Web Services, and Google Cloud Platform. Spark requires a cluster of computers to be set up, and Databricks automates this process. So it's as simple as choosing the number of computers and the size, and Databricks handles the rest. On top of that, Databricks will handle auto scaling. So you pay for the computing power you are actually using. This can mean big savings if you are using occasional analysis that requires a lot of compute power for short periods of time. Databricks works with the Spark engine using code written in notebooks. This allows users to work in a mixture of languages supported by the Spark platform, whether it's SQL, R, Scala, or Python, choosing whichever language the user's most comfortable with or whatever is the best for the task at hand. It is also having a number of popular machine learning frameworks built in, again simplifying the setup so that data scientists can go straight in to whichever framework is best for their analysis without having to worry about installing it separately and instead spending their valuable time on the analysis. And now, probably the most important thing, Databricks has enterprise level security built in and a lot of notebook means for effective collaboration. Now, just to give some context, I'll run down a couple of components. So Databricks workspace will be set up in AWS or Azure or GCP, but the workspace itself will be on Databricks Online. All the coding and data storage occurs within the tool. Within the Databricks workspace, we need a cluster and a notebook. The cluster has one main computer called the driver node and several other computers called working nodes. The driver interprets the run commands, and actual processing workload is distributed across worker nodes. The cluster is easy to set up, and clusters differentiate by size of machines and the number of machines. Notebook, on the other hand, is made up of cells of code, and each cell has its own output. The notebook may be run as a whole, with each cell running in sequence, or individual cells can be run as well. Now, the above is an end-to-end architecture diagram of using Databricks within Microsoft Azure. We are using Databricks to transform and enrich the data, like removing duplicates, helping with internal external data mapping, clubbing data with various sources, or adding any specific business logic, and then storing it in Azure SQL database or Azure Synapse Analytics, Azure's data warehousing offering based on data volume, and then utilizing any of the reporting tools like Power BI, Tableau, or even Excel to gain insights from it. Also, from a very high level cloud vendor perspective, Microsoft Azure offers advantages for organizations that are already heavily invested in the Microsoft ecosystem. Offerings like enterprise agreements, Azure hybrid benefits, they allow organizations to save money on cloud resources with closer net integration options between on-prem and cloud services. In addition, organizations typically leverage Azure Active Directory to better integrate their AD environments with existing on-prem user provisioning and user management. Similarly, here's the sample architecture diagram of how Databricks can be used within an AWS architecture. Again, Databricks sits in the exact same position, helping with processing and enriching data with exactly the same business logic code, and then using services in AWS stack for further data warehousing needs. For example, in this case, either using Amazon Relational Database Service or RDS or Amazon Redshift, Amazon's petabyte scale data warehouse offering based on needs, and then using any reporting tools for gaining insights. From a cloud vendor perspective, Amazon Web Services is recognized as one of the most mature public cloud vendors with the broadest range of services and even has a very fast rate of releasing new services or enhancing existing ones. It is also seen as the market leader within the infrastructure as a service space and are putting in huge focus on their machine learning stack. And finally, here is the sample architecture diagram of how Databricks can be used within a GCP architecture. From a cloud vendor perspective, Google Cloud Platform or GCP is recognized for its strong machine learning and AI services. Google has really been a pioneer in this area and has developed on open source frameworks like TensorFlow, which in turn gets used within services within the Azure, AWS, or even Databricks. And GCP recognizes that they have been third to come in this cloud vendor space. So they are coming up with strategies for making it easy for customers to move between different cloud platforms because they want to take the customers who are already on AWS and Azure. Even they have improved Kubernetes, which is a container orchestration system, making it easier to move containerized apps from one cloud platform to another. Now, as you might have noticed, Databricks makes it extremely easy to migrate across cloud vendors without any change in the logic for your ETL, extract, transform, load. It provides APIs to help connect and move data across cloud vendor services, taking in advantage of any of the above discussed cloud design patterns. Few challenges of the multi-cloud approach currently in the market. The first one is management. How do you manage all these services and resources in different cloud platforms? There are a few services provided by the cloud providers to help in this space. For example, Azure Cost Management supports all three platforms. Or let's say third party tools like Terraform, which has plugins for service provisioning in any of the three cloud platforms. Then, if we are using any multi cloud design patterns, let's say multi cloud high availability, there will be challenges like maintaining data consistency across platform services for that application. In addition, a strategy is required to retrieve the data in the fastest and most cost effective way across regions. Currently, different cloud providers use different APIs, different security controls, frameworks, and authentication mechanisms. So there's a lot to consider when coming up with a multi cloud identity and access management approach. And then finally, as the number of services increase, we will require a wider area of expertise and technical knowledge. As you've seen, there are a lot of things that needs to be understood and considered when you're putting together a multi-cloud strategy and when you are ultimately implementing one. The initial paper assessment, I would say, is crucial. Where are you now? What reasons do you have for leveraging certain tools? What are the constraints and requirements for various services? What are you contractually logged into? Moving forward, how much are you intending to use analytics? What are your goals for the future? There are a lot of questions that can be asked, and a paper assessment is what will help clarify and help find a business use case for your multi cloud strategy. Once you have a strawman and a proposal together, there may be some internal external negotiations, but in parallel, you may start POCing, just coming up with a proof of value for different use cases for migrations to tangibly see how transitions may unfold, leveraging the small scale learnings, more efficient, larger scale implementations, and honestly knowing that your roadmap is likely multi year. It should probably be highly modularized and be able to be flexed as requirements change, tools change, and new players enter the market. It is important to have strong research findings and arguments for an initial plan, but you need to remain agile as the landmark is quick to change over time. That's all I had time to cover today. Thank you again for joining me today. Please don't hesitate to reach out if you have any questions. Have a nice day. Thank you.